Alright, geometry, here we are with areas of circles and sectors. Okay? And a sector is going to be a piece of a circle. It's like a slice of pie. So for the area of the circle, our formula is area equals pi times radius squared. Pi times radius squared, or pi r squared. Find the exact area, and then find the area to the nearest hundredth. Okay, so when we're talking exact, we leave pi in the answer. So if we have radius of 6, it's pi times 6 squared, or 36 pi inches squared. And then if we approximate it, we would type that into the calculator. 36 times pi is usually going to be a second function, and then on the graphing calculators, it's your power arrow key there. 36 pi. 113, what are we supposed to round to? Nearest hundredth. Okay, that's going to round that up to a 0 to a 1, so 113.10. Okay, this one says the area of a circle is 106 square centimeters. Work backwards to find the diameter. Okay, so we're actually going to go in reverse, get the radius, and then we'll make that a diameter. So 106 equals pi r squared. Okay, we're going to divide by pi. 106 divided by pi. Use the pi button as much as you can. I know that maybe junior high, they told you just use 3.14. You're going to want to use that pi button as much as you can with these problems. So we have 33.74. Okay, now we're going to square root. We'll get 5.81 for our r. Okay, then we're going to take that times 2 to get the diameter. And that's going to be 11.62 centimeters. Okay, so that was going forward, and this is having the area given to you and going backwards. We okay with that? Okay, a sector is a region bound by 2 radii of the circle and their intercepted arc. Okay, it's going to be a piece of the circle, a fraction of the circle, a piece of the pie. The ratio of the area of a sector of a circle to the ratio of the area of the whole circle is equal to the ratio of the measure of the arc to 360. So just like what we did yesterday with pieces there of arc, the arc length, we did arc length is the fraction of the circle times your circumference. Okay, to get your area of a sector, it's going to be your fraction of the circle out of 360 times pi r squared. Okay, so down here we have 90-degree angle. So that's a 90 out of 360. We know that's a fourth times pi times 6 squared. So times 36 pi. Okay, a fourth of 36, that'd be 9 pi centimeters squared for our exact. And our rounded would be 28.27. Okay, let's hit pause here and have you try that. Okay, welcome back. Let's see how you did here. We're going to have 60 out of 360. Hopefully we can recognize that as 1/6 times pi times 10 squared. So times 100 pi. 100 over 6 is going to reduce to 50 pi over 3. And 52.36. And that's going to make sense because pi is just barely bigger than 3, so we're not expecting this to get a whole lot bigger than 50. Inches squared. Okay? So fraction out of 360 times the area of a circle. Not too tough. Use the diagram to find the indicated measure. Find the area of circle S. Find the area of circle S. Okay? So this area is for the shaded part, or for our sector that's just under half of a circle. So I know my area of that piece was 39.52, and that would equal 175 out of 360 times the area of my circle. Normally I would go pi r squared, okay, but I'm going to say that pi r squared is the area of the whole circle S. So I'm just going to call that A. We had a few problems like that yesterday with circumference, where if you did the whole long formula, you would have gotten your radius, and then you'd have to go forward and find your circumference. That would have been the same thing. You'd have gotten your R, and then you'd have to go forward and find the area of the whole circle, where part of that formula was pi r squared, which would have been the whole area of the circle. So we're going to save ourselves some time right here. Okay, so just times 360 over 175 to cancel out this fraction. 360 over 175. 360 divided by 175 times 39.52. And our whole area will be about 81.30. These are labels here, inches squared. This one, we actually have to go all the way back to the radius. Find the radius. So the whole thing was 20.89 equals 70, well, 78 is the unshaded. So what would be shaded? 360 minus 78. So that's going to be 282 degrees. Times pi times r squared. So we're going to go 360 over 282 to both sides. And we should be getting 26.67 equals pi r squared divided by pi. And we'll get 8.49 equals r squared, and we're going to square root. We'll have about 2.91 for our r. Okay, so we might have to work backwards with some of those. Find the piece that they want. Last example problem for the day is an annulus, a donut, a ring. Okay, we got two circles, one inside the other there. Find the area of the shaded region. So that's a big circle. And then it looks like we're taking out the center. So it's more like a donut there. Okay, we got the whole circle, and we're taking out the middle of the donut. So the whole circle has a radius of 4, the big one. So we'll have pi times 4 squared. And then we're going to take out the little one, pi times 2 squared. So 4 squared is 16, so we're going to have 16 pi minus 4 pi for a total of 12 pi inches squared exact. And if we were to multiply that out, 12 pi, 37.70. Okay? Going forward, if you have like an annulus type of problem, a ring or a donut or a bullseye kind of problem, we're going to go with pi times capital R squared minus pi times little r squared. Capital R, big R for the radius of the big circle, minus pi r squared with a little r for the little circle. Okay? And there's your homework. Enjoy. We'll see you tomorrow.